Welcome back. In this class, we are going to talk about musical notes. What are musical notes? We need to understand very well where notes come from to be able to compose music. Everything has its origin in physics, which is why music is closely related to mathematics, and we'll see why. We have this sound. It's the string of a guitar. String instruments are precisely some of the oldest in humanity. If we take a string, stretch it, and block it, we'll produce a frequency with its respective harmonics. And since ancient times, people realized that if we take the same string with the same intention but half the length when plucked, it will generate a sound whose frequency is exactly double. This works in the opposite direction too. If we take a string with the same tension but double the length, the frequency will be exactly half of the original. These types of frequencies that are double or half of another are called octaves. As you can see, it's very easy to find octaves because we simply multiply or divide by 2. Returning to strings, they realized that if instead of cutting the string in half, they cut it into 2/3, it also generates a frequency that sounded pleasant when played at the same time as the original. These types of frequencies are called fifths, and of course, each fifth can also be multiplied and divided by 2 to find its octaves. If we repeat this process 12 times, that is, taking a frequency, dividing it by 2/3 and then finding its octaves, there will come a point when the generated frequencies will no longer be new, but will be the octaves of some of the frequencies obtained before. These 12 frequencies correspond to each of the notes on a piano. The seven white keys, and the 5 black keys. And this pattern of notes repeats throughout the keyboard. Historically, the frequency used as the base from which we obtain octaves and fifths is 440 Hz, which corresponds to this piano key. Now then, it's time to assign names. Let's start with the white keys. The base frequency of 440 Hz is the letter A, followed by B, C, D, E, F, G, and back to A, but 1 octave higher. Therefore, these 3 notes have the same name, but in different octaves. To differentiate the octaves, a number is usually placed next to the letter. For example, the central note of the keyboard is C5. And the note corresponding to the frequency of 440 Hz is A4. The black keys do not have names by themselves. The black keys do not have names by themselves. The black keys inherit their name according to the white keys they are next to. The first black note is immediately to the right of the C note. Therefore, is called C sharp. This other note, for example, is immediately to the right of F, therefore it's called F sharp. But they can also inherit their name in another way. For example, this note is immediately to the left of the E note. Therefore, we call it E flat, or the first black key we saw is immediately to the left of the D note. Therefore, it can also be called D flat. With this, we realize that the same black key can have two names. Both are valid, but we will use one or the other depending on the musical scale, which is something we will learn later. For now, the important thing is that now you know why some notes sound good together, like octaves or fifths. It's because their frequencies have a mathematical relationship that our brain can easily understand, and the notes that don't sound so good together is because their mathematical relationship is more complex. So you have two tasks. The first is to memorize the names of the white and black keys. The second is to experiment with which notes sound good together and which don't. For example, select the note C and play it at the same time as C sharp. How does it sound? Now repeat with C and D. How does it sound now? And what about C and E, F, G, and so on, with all the notes to begin discovering harmonic relationships between notes. In the meantime, see you in the next lesson.